So in the example of Java-like string in C++, we could also benefit from a few operators that would provide convenience for our users, and possibly we could add operators that allow comparisons for equality, inequality, less than, greater, and so forth, this whole family of operators. So what could we use for potential implementation for these operators? So this is a little tedious, and we could possibly envision in our implementation of these functions just basically do something like this. So I just copy and paste examples of these operators. So once again, this here, these are just operators that are declared as non-member functions. They are outside of our class string, but they're expecting string to be passed as a left-hand side and right-hand side. Of course, none of these operators are expected to modify our strings, so of course we pass our strings by constant reference as left and right. And this is an implementation. So it's really a fantastic case when you can rely on already existing member functions, and I always postpone operator overloading till the very end of my class design, and this is just a mere convenience. But when you have member functions that are already designed to do the same work, that's just perfect, because one line of code could implement it and do the work. So here there could be two possible ways to implementing equal, basically comparison of one string to another string, by also using compare to and checking its result equals 0. So you can roll back to the discussion about compare to function, and both of these could be used. So then once the operator equal is in place, it's possible to use either one of these and invert the result. So basically say return not left equals right, basically repeat this call. But another pretty standard technique is actually, you probably don't want to duplicate this code in too many places. Instead, you want to rely on what this does in other places as much as possible. Then, in that case, you can call this operator equals for the left and right, and it will of course return true if left and right are equal, because this will be the call going into operator equal. But then we invert the result, and that achieves the desired outcome. So we say that this should be true when left and right are not equal. So that's a standard technique, basically rely on other operators in the implementation of some of the operators that simply derive themselves from here. Now here's a less than and greater than. Those are pretty straightforward. We basically use the compare to, and remember, less than for the left and right returns essentially a negative result. So we just compare it with a less than 0, and that should give us the outcome of less than. And operator greater than is the opposite. It basically says let's compare, and if the result is greater than 0, then you've got the greater than condition. Now combination of less than equal or greater than and equal, in those cases we can just combine operator equals and operator less than using the logical OR operator, and basically what it will do, it will call this function first, check for the equality. Of course, if the equality says yes, it's true, then we're all done. compiler will automatically short circuit this evaluation at this stage, because we already have a true result for the OR operator, and this will never be invoked. However, if this returns false, then we'll have to call this one, and this one will delegate the result to compare to, and if it's true, then we will still be returning true. The same is happening with the greater or equal. So this is a very standard, a little tedious, requires plenty of testing, but that's the technique. You just declare all of this, whatever operators you want to have, and you just begin to work on your implementation. I would strongly suggest that when you use non-member functions to work with your classes, and you find yourself writing lots of code in these operator function implementations, I would strongly suggest that you probably need a member function that does the work. You probably want to rely on a member function in your class that does something that your operator is trying to represent conceptually. Comparisons or arithmetic or unary or binary operations. Typically your implementation here should be just like really short. It should not take the whole page of code. If that's the case, you probably should have a member function that does the work inside your class, and then call it from your operator implementation.